All right, let's look at the homework 2.1, problem number 3. All right, so we have, let's see, displacement of a particle moving a straight line given by, right, so S is equal to t squared minus 7t plus 19, right? Then we want to find the average velocity over these intervals, all right? I'll do just part 1 because everything else is, works the same way. All right, so interval is 3 to 4. So if you want to find the average velocity, all you really have to do is this. So here's the average velocity. All right. So this is just distance traveled would be just s of 4 minus s, so this is a position of the beginning, so which is at t equals 3, and 4 minus 3, right? Then we just have to plug in, so the bottom is 1, so I'm not going to even write that down anymore, but s of 4, so you just plug in 4, so that would be 4 squared, so that's 16, and negative 7 times 4, negative 28, right, plus 19, right? So that's S of 4. Then you have to subtract. S of 3 would be, let's see, plug in 3, so 3 squared is 9, and negative 7 times 3 is negative 21, and then plus 19. Oop, I miswrote that, so it's a plus 19. Right, and over 4 minus 1 is 1, so I'm not going to write that. Right here, so 19 minus 19, so we'll cancel out, so we don't have to worry about that. And then this is going to be equal to, all right, so let's see, so you have a 16 minus 28 would be negative 12, right? And then here, so it's a minus 9 plus 21, so that would be, let's see, plus, all right, what would that be, plus 12? So it's plus 12, right? So luckily, actually, this is equal to 0, right? So let's type that in first, right? So we found that to be 0 is the average velocity. All right, so let's see if I got this correctly by submit for testing. All right, looks like we got this one correctly, and I believe that you guys can do these three problems in 3 parts. You just have to change the number to 4 to 3.5, 5 to 4, and 4.5 to 4. So it's the same deal. All right, then let's look at the part B. All right, part B. So I'm gonna just get rid of these guys and move this guy up a bit so that I have some room to work in. All right, so let's try. So we want to find an instantaneous velocity. So this is a derivative. So we want to find s prime at 4. Right. So we can do that by taking a limit as h approaches 0, and s of 4 plus h, right? So s of 4 plus h, so every time you see t, we put the 4 plus h in there. So you have, right, so 4 plus h squared, can I go ahead and just multiply out? Square would be 4 plus h squared would be 16 plus 8h plus h squared, right? So that's 4 plus h squared minus 7 times 4 plus h. So 7 times, so minus 7 times 4 would be negative 28. Negative 7 times h would be negative 7h. Right? Then you have plus 19. Right? So that's s of 4 plus h. So I'm gonna clean up a bit. So here, and so we know that what this guy is. So this is s of 4 plus h. right? Then you have to subtract s of 4. So maybe I'll write s of 4. Right? So you plug in 4 in there. So 4 squared would be 16. And minus negative 7 times 4 is 28. And plus 19. Right? Then all over h. Right? So this is just the s of 4. Right, I'm just going through the definition. All right, then we can clean up a bit. So you have 16 minus 16, and negative 28 minus negative 28. 16 minus 16. Right, then what's left would be, right, there 8h and h squared, and then they have 7h. Right, that's it. Right, so let's clean that up. So you have a limit as h approaches 0. Then you have h on the bottom. Alright, so on top, let's see, I'm going to combine 8h and negative 7h, so that will be 1h. Right? So I'll pull out the h first, because everyone has h. So pull out h from h squared, you have h. 8h and the negative 7h combined is just h. So if you pull out h, so you're going to have just 1. All right. So we can cancel. So we actually didn't need this much. So we can cancel h's. So we can cancel h on top and h on the bottom. Right? Now h goes to 0. So you have basically 0 plus 1, which is going to be 1. Right? So instantaneous velocity is 1. So let's type it in. Right? So we found that to be 1. Right? So let's go check. All right, it came back and looks like we got part B correctly. All right, that's it. I hope that this was clear.